Hey everyone, and welcome to second episode on LINQ. I'm Munir Hossain, a senior software engineer, tech enthusiast, and architect with over a decade of experience working on .NET platform and a part-time instructor at whyweuselinq. In this episode, we are going to dive deep into language integrated query or LINQ, one of the most powerful and efficient features in C#, and see the power of generics, extension methods, and delegates when used together, the LINQ. Now, if you have not downloaded and installed Visual Studio, I suggest you to download it first from this link. Depending on your choice, however, you can work on any editor, but I will be using Visual Studio 2022 tool code. Just to fill the bill, let's first see how Microsoft defines the so-called LINQ. She says, language integrated query, the LINQ, is the name for a set of technologies based on integration of query capability directly into C# language. Or we can say LINQ, the language integrated query, is a feature in C# that allows you to query, manipulate data directly within the C# programming language using a syntax integrated into the language itself. LINQ provides a unified approach to work with different types of data sources such as collections, databases, XML, and more. It says querying capability, which effectively means we can select, filter, order in memory collections or remote data source and much more right inside the C#. Isn't that incredible? If you ever have worked with SQL Server and ADO.NET, you know how creepy it was to fetch and manipulate data and working with store procedures. And even with the in-memory collections, all of these problems are solved by LINQ. We will create and code together to solve the first problem practically here at whyweuselinq. I highly recommend to code along with me to get most out of this episode. Okay, let's begin.
I have already fired up Visual Studio and created a starter project in it. The project will be available on my GitHub account just in case you need it. Okay, let's have a quick look at what I have created and what's the purpose of the code. Let's open the Solution Explorer and check out this customer class. Okay, we have some properties and a constructor over here. Let's check out the properties first. We have a customer ID over here. This is an integer which uniquely identify each customer in the system. It's common practice to use IDs to ensure each customer can be tracked separately, even if they have the same name or email. Next up, we have this first name and last name properties. These are string representation of customer first name and last name. Together, these allow us to build a customer first name, which is accessible through this customer full name property. As you can see, it combines the first name and last name to return a formatted string. This is done using a simple interpolated string, first name followed by the last name. Okay, then we have this email and phone number. Both are strings and they represent the customer's contact information. This is essential in any system that needs to reach out to customer or send them notifications. Then we have this address, city, and country property. These properties helps us to store customers' physical location. While we are not validating the address here, you could easily add more advanced text in real-world applications. Then next up, we have date of birth and registration dates. The date of birth is a datetime property. This helps keep track of when the customer was born and can be useful for things like calculating age or offering age-specific services. The registration date tells us when the customer is registered in the system. This is also datetime. Then we have this isActive property. This is an important one. This is a Boolean value that tells us whether the customer account is active or not. It's useful for account management, such as whether a customer can make purchases or access certain features. Then we have the salary property. This is a decimal representing the customer's salary. In some systems, this might be used for income verification or salary related features. Then we have last up, we have this customer constructor. The constructor allows us to create a new customer by providing values for all of these properties. For example, when creating a new customer, you would pass in a customer ID, first name, last name, address, salary, etc., so that a new customer can be created. So let's close these down. So that's pretty much it about the customer class. You can see that this class is simple yet powerful representation of a customer in your system. Of course, in real world applications, you will probably add more validations, methods for business logic or database interaction. But this is a great starting point. Next up, we will be looking at customer service class. Let's open it. Customer service class. Uh, this is a simple class which randomly generates 100 customers for us. Inherits from customer service interface. This interface have only one public method which accepts nothing and returns a list of customers for us. Back to customer. Let's have a look at it. Okay. So here is the customer class, and its purpose is to fetch customer data. Imagine this is an API call, and instead of pulling this data from the database, we are simulating it with random data. Let's break it down. Let's open the function. This class have only one public method, the get customer, which is responsible for generating a list of customers. You can think of it as an API endpoint that would return a customer information. In a real world scenario, this method would be fetching data from an external API. But for this example, we are just generating random data locally. So if we have a look at it, we have a random data generation to create realistic customer details. We start with sample data array of first name, last name, city, country, this one, and this will simulate the diversity of data that we might get from an API. So next up, we are looping through these lists, and then we are randomly generating first name, last name, email, city, and registration and salary. So for example, let's take the example of this. Here we are generating first name and last name, and then we build the email address based on selected names. So for instance, if the first name is John and the last name is Dio, the email will look like this: john.dio@example.com. And same is the case with other properties. So once we have random values, we create a new customer object and add it to the list over here. This process is repeated 100 times, which gives us a list of 100 customers. Each customer object is populated with generated data and added to customer list, which is returned when method finish running. So now we have created our customer list. Imagine this customer service is a part of an API that your front end can call to retrieve data. In real world scenario, you might use HTTP client or HTTP client factory to send a request and receive a list of customer. And remember, in the real world application, you would replace the random data generation with actual calls to an external service. That's pretty much about the customer service class. Next up, we have this customer data over here, which inherits from customer data. Let's have a look at it. So we have two public methods over here. One is customer where, and another is print. So the customer where accepts an enum, customer filters, and the salary. Based on the salary, based on the filters passed in, we just filter out the salary. So let's go to this filter, and it has only one member, which is greater than. So, and then this print function prints out the list of customers for us. And let's go back to the customer. This customer data constructor, we have a constructor over here, which herein we inject the customer service here, and then we have this customer service is assigned to a private read-only property customer service. So then we have this customer where function, which let's see what's inside. We are creating a list of customers over here, some checks over here, and we're getting the customers from the service we just injected in the customer, and then a null check over here, a count check over here, and then this is the center of focus of our whole video. Why we use LINQ, and then we check the filter customers. If it is customer filters dot greater than is passed in, we just loop through the customer service data over here, and then we check if the item dot salary is greater than the incoming salary which is passed in, and we just if it is, we are just adding the item to the filtered list of filtered customers over here, and then we return the customers back to the caller. This function will be the center of focus of our whole video here. So let's have a look at what's another function. This is a print function which accepts a list of the list of customers over here, and then it consoles some of the properties of this customer items here, and that's pretty much about the customer data. Okay, guys, that was pretty much about the customer data. Let's make an instance of this customer data class and filter out the list based on the salary. So over here we are making the instance of customer data class and inject the customer service. In real world scenarios, you should in fact you must use some dependency injection container like Microsoft dependency injection container, or simple inject engine, or any other dependency inject depending upon the requirements of your project. So I highly recommend to use dependency injection container to inject the services into the constructor. So this is here we are filtering out the customer data where salary is greater than 40,000. So then we just use the customer data's print function to filter out to console it to the output. So let's run this program class and this static mean method, and then let's see what is the output. So here is the output. We have this customer ID, name, and the salary, and the list is just filtered out. So let's have a look at customer data class. So here we will be filtering out the list. So we successfully filtered out the customers where the salary is greater than 40,000. But the product owner comes in and throws another requirement. She says that we should also have a capability to filter out those customers which which have salary less than 40,000. And to satisfy her, let's go to implementation and just copy it over and paste it over here. We just have to change this to dot less than, and here less than. And he again comes in and says, okay, show me the customers which have salary equal to dot equal to, let's control period, and let's control period and enum member, generate an enum member, or they are in the enums. So let's go to program class and test this equal to functionality. Seems there is a problem over here. I have not changed the thing. Okay, so it should be equal to over here. Let's run it again. So seems there are no customers having salary as 40,000. Fine. So that's fine. Let's test this functionality. You just have to change dot less than. Let's see if we have customers less than who have salary of less than 40,000. Okay, those are the customers. By now, you should have a clear understanding and should have realized that this solution is clearly not a good one. Every time the condition changes based on the salary, we are adding a new if block. And even worse than that, if this salary thing changes, say suppose we are based the condition on any other property, we have to write down the entire function from top to the bottom. So let's figure out what is the problem over here. So the first problem is the if block. Is there any way by which we can pass in the condition, and that by that condition we can just loop down the list and return the filtered list back to the caller? So turns out there is some functionality over here. There is some facility if we combine the power of generics, extension methods, and delegates over here. So the delegates will pass in by delegates we will pass in this condition. By extension methods, the list will be inherently passed in, and by generics we can pass in any type of list. So it turns out that every collection in .NET inherits from iEnumerable of T. So we can exploit this property to write down our functionality and clear out this code. And let's write down this generalized function over here. Let's add a class, static class over here. Name it as LINQ extensions. So finally you are on LINQ. Congratulations. Add. So let's make it public and static. Let's extend the iEnumerable of T interface. Public iEnumerable of T. It will be returning iEnumerable of T, and it will be a static function. Let's name it as filter, and we are extending iEnumerable of T. Right? So it will be, the function will operate on T. We have to pass it over, and let's name it as list, and let's pass down the condition as func. This is an inbuilt delegate. Here we will be which will accept the T and will return the boot. Let's name it as condition. So we'll be checking out here if we'll be looping through for each where item in the list, this list, which will be passed inherently because we are extending the iEnumerable of T, which every collection inherits from. So we will be if condition of item, and then we will be yielding the item. Right? That's pretty much it. So seems we have a missing braces over here. Okay, that's pretty much it. So let's go over it. So this is a static extension method in which we are extending the iEnumerable of T. Every collection inherits from iEnumerable of T, and when we extend this interface, it will be available on every collection, lists, dictionaries, any of the stack, queue, everything. So then we are passing the delegate as condition, right? So the condition will be passed in by the user as a function. So this condition will accept the address of the function, and then we are looping through list, and we are just making use of this condition, and this condition will call back to the caller, and then yield return item. If you are wondering what is this yield return is nothing but it's part of like lazy loading, which wherein we don't have to make any list to add, like we make the nib it up list and then add it, and then back to the caller. So that thing is not happening here. So this yield return will not be triggered unless and until a for each or any other function in which the for each functionality is written in, like to list in C# or LINQ. Or another thing is here we are just extending the iEnumerable. Make note of this also. Let's go back to this customer, I think, data. Yeah. Yep. And we will just get rid of this all code. And in fact, we don't need this customer service over here. So if we do that, we have to, let's write a new function over here. We are not going customer salary filter, right? So we are not going to do any of these things. Let's see, everything is cleared up here. So let's do one thing and filter out this list, customer service dot filter x such that x dot salary greater than 40,000. Fine. And we just have to return it. Fine. And of course, we need to trigger it. Or we just have to make it IEnumerable of customer. I think since there is some problem over here. No. So that's pretty much it. So let's go to program.cs and see dot filter salary customer, and or we can just do one thing. Let's have it like this, and let's print it out to list. Right. So if you are wondering, this to list, this will trigger the for each loop and give us the trigger the for each loop and give us a new new list back over here. So this to list will be will change the IEnumerable of t to a list and give a concrete list back to us. So that's pretty much it. So let us run it and see how things are going on. Seems we have some problem. So okay, let's get rid of this interface for now. Okay, we have every customer having salary greater than 40,000. Okay, one more thing. Let's do one thing. Let's go to customer data and restore it. And let's go to customer interface, go to definition, and let's name this as get customer. Or we don't have to make use of this customer anyways. Let's do it. So, and then we'll have to get customers. So let's get rid of this and return the list back to the caller. Now let's go to program.cs class and here dot get customers. Fine. And here like name this as customers. Let us customers dot filter x such that x dot salary less than 40,000. Fine. And let's have this as to list and where customers or filtered customers print. Fine. And that's pretty much it. Let's run it and see the output. There is some error, customer data. Okay. Seems we have the problem with the interface. Let's run it. There is some problem. Let's implement it and implement interface. And let's cut it down and paste it over here and get rid of this. Okay. Let's run it now. We have some problems over here. Customer does not have a definition of get customers. Okay, now it's complaining here. Dot get customers. So since there are no customers, okay, salary less than 4,000. We were having 40,000, right? Okay, less than 40,000. Oh, okay. By the way, this list have the same effect as for each loop. If we get rid of this for and get rid of this to list and go to print function, go to definition, and here we will just IEnumerable of customer, we should be pretty much okay with the thing, right? So here in the print function, we are using using the iEnumerable and using for each loop. So the error has gone, right? So let's again run it and see. No. Okay, we have the problem with the contract now. So that is iEnumerable of customer. Go to definition. That is iEnumerable of customer, right? Okay. Let's print it out now. I think it should not complain now. Okay, here we go. So we just clear out everything, every mess out of this customer data and move the functionality here. And it's clear and concise. If we want to filter out customers based on salary, say suppose greater than 40,000, we can do that. If we have something like filtered customer like 3 on any other property like date of birth greater than date of birth, say suppose date time dot now, we can have less than date of birth less than every customer which is born less than. Anyways, that's not a practical thing, but demonstrated purposes that serves fine. Or we can do anything without writing any custom code. A little bit of code will make the difference. Like we have customer 4 over here, and we are just making a list dot starts. I think we have got dot first name, full name dot starts with S, starts with say suppose J. So we are making good use of this generics. You should now have realized the power of generics, delegates, and extension methods. So guys, this is all about LINQ. All linked objects are implemented like this. So you can try out yourself if you want any other functionality. Just in case you are curious to know about all of the functions, extension functions in LINQ, just type enumerable. This is a class which is extension class, where all extension methods to iEnumerable of T are defined there. Let's go to definition over there. See, we have aggregate, we have like all, any, append, we have average, we have, see, all of these functionalities, see, are written over here. All with generics, extension methods, and these delegates. So hope guys, I'm able to make you understand the power of generics, extension methods, and the delegates with the use of LINQ. Thank you.